Exploring Earth's core heat. Why are oceans cold? Hey everyone, and welcome. Today we're diving deep, literally, to explore a fascinating question. If Earth's core is incredibly hot, why are our oceans so cold? It seems like a contradiction, right? Let's unravel this mystery together. We often hear about the Earth's fiery core, but its relationship with our planet's surface temperature, especially the oceans, is more complex than you might think. Get ready for a journey from the center of the Earth to the bottom of the sea. First, let's quickly review Earth's structure. We have the crust, the mantle, the outer core, and the inner core. The inner core is a solid ball of iron, while the outer core is liquid iron and nickel. The mantle is mostly solid rock, but it can flow very slowly over long periods. And finally, the crust is the thin, outermost layer we live on. It's important to understand these layers to see how heat flows, or more accurately, doesn't flow easily. So, how hot is the Earth's core? It's estimated to be between 5,200 and 5,700 degrees Celsius. That's about as hot as the surface of the sun. This heat is primarily left over from the Earth's formation and from the decay of radioactive elements. This intense heat is constantly trying to escape. But why doesn't it just melt everything and boil our oceans? That's where the mantle comes in. The mantle acts as a massive insulator. It's about 2,900 kilometers thick and made of rock that isn't a great conductor of heat. Think of it like a giant rocky blanket. Heat from the core does make its way through the mantle, but it does so very slowly through a process called convection. This is where hotter, less dense material rises and cooler, denser material sinks. This convection in the mantle is what drives plate tectonics. The slow movement of the mantle causes the Earth's crust to break into plates that float on top. These plates move and interact, causing earthquakes, volcanoes, and mountain formation. Volcanoes are a direct result of the Earth's internal heat reaching the surface. But even volcanic activity doesn't significantly warm the oceans on a global scale. On top of the mantle, we have the crust. The crust is relatively thin, ranging from about 5 to 70 kilometers thick. It's another layer of insulation that further slows down the transfer of heat from the Earth's interior to the surface. The crust is also made of rock, which, like the mantle, isn't a very good conductor of heat. This means that only a tiny fraction of the core's heat actually makes it to the Earth's surface. So if the Earth's core isn't heating the oceans, what is? The answer is simple: the sun. The sun's energy is the primary source of heat for our oceans. Sunlight warms the surface waters, and this heat is then distributed by ocean currents. These currents play a crucial role in regulating global temperatures. Ocean currents act like giant conveyor belts, transporting heat from the equator towards the poles. This helps to moderate temperatures around the world. Without these currents, the equator would be much hotter, and the poles would be much colder. Think of the Gulf Stream, for example. It carries warm water from the Gulf of Mexico up the eastern coast of North America and across the Atlantic to Europe, keeping those regions much milder than they would otherwise be. Now, there are places where the Earth's internal heat does affect the oceans directly. These are hydrothermal vents, often found near volcanically active areas on the ocean floor. These vents release superheated water and chemicals from the Earth's interior into the surrounding ocean. They create unique ecosystems that thrive in the absence of sunlight, relying on chemosynthesis instead of photosynthesis. Even with hydrothermal vents, the overall impact on ocean temperature is minimal. The vastness of the oceans and the insulating properties of the mantle and crust mean that the core's heat simply can't overcome the cooling effects of the atmosphere and the sheer volume of water. The oceans are constantly losing heat through evaporation and radiation. This, combined with the limited heat flow from the Earth's interior, keeps the oceans relatively cold. So, there you have it. The Earth's core is incredibly hot, but the mantle and crust act as effective insulators, preventing that heat from significantly warming the oceans. The sun remains the primary source of heat for our oceans, and ocean currents play a vital role in distributing that heat around the globe. It's a complex system with many interacting factors, but understanding these basics helps us appreciate the delicate balance that makes life on Earth possible. Thanks for joining me on this journey from the Earth's core to the cold depths of the ocean.